Hi, in this lesson we're going to take a little bit different approach to working with our linear equations, as well as take a look at a new notation. In this first, we're going to look at these in sets of 4. In this first set, we have 4 different graphs that we are going to match up to 4 different equations. But if you look at the equations, the notation is a little bit different. If you look at this first one, we have a and then parentheses x, closed parentheses, is equal to 4x plus 5. The second part here looks very similar to the y equals mx plus b, and it is. It's the same thing. The 4 is our slope, the 5 is our y-intercept, but this a of x, it's how we say this, is a little bit different notation. It's basically our y, but we use this notation. It's called function notation. And it's called that because it really reiterates that the whole idea of the y is totally dependent upon whatever x is, that you plug x into this equation to find out what your y is. So it's just a notation that reiterates the whole idea that the x is the independent variable, the y is the dependent variable, the x are the inputs to our equations, the y's are the outputs. So it's just a little bit new notation, but the same meaning. So what we're going to do is we're going to take a look at each of these equations as well as each of these graphs and try to match them up. So looking at this first one, a of x is equal to 4x plus 5. This 4, I could think of it as 4 over 1, so it's in fraction format, so I can recognize change in y over change in x looking at that ratio. I recognize that 5, this is going to be crossing the y-axis at 5. So that's going to be crossing the y-axis pretty low. So these last two don't really count because we're looking at an x-axis of y to 50 and a y-axis of, 0 to 50, and the same thing with our y-axis, 0 to 50. The other thing is that this 4 over 1 is a positive slope, so it means it's going to be rising going left to right. But this first one probably isn't enough because we're rising 4 and going over 1. If we look at the second one, that would make more sense, that we're crossing at 5 and possibly rising 4 units to go over 1, up 4 over 1. Now I know I'm kind of exaggerating that there, but this one looks pretty obvious that this would be our function a. Okay, so our next one, we have a negative slope. Okay, so it's probably going to be one of these last two. And it looks like we're going down 1 and over 2. Whereas this one, we've got a negative slope. Again, this is like an implied 1 or an implied negative 1 over 1. But this is going to be a little more subtle, down 1 and then over 2. This is going to be pretty constant. So it looks to me like this would be down 1 over 1, down 1 over 1, kind of a perfect stair step. So this one would be C. Back to looking at this one, this looks like it's be down 1 over 2 and looks like it crosses about 48. So that makes sense. So that this one would be B, and that leaves this one to be D. Let's double check it though. The D is actually 1 over 1x plus 8, so it's up 1 over 1. This is a positive slope. Looks like it crosses at 8. That makes sense here. That looks like we're going up 1 over 1, up 1 over 1, just a perfect staircase. And that kind of makes sense. So anytime it's 1 over 1 like that, or down 1 and over 1, that's that perfect stair step, that perfect diagonal, going one, either increasing or decreasing. Okay, same scenario in this second set. We've got 4 different graphs and 4 different equations, and again, we're using that same function notation, and it's just naming the equation, that x in the equation A, this is equation A, what does it look like? So I'm going to start with, it crosses pretty high at 47, and it's down 5 over 8, so it has a negative slope. So these last two, again, have the negative slope. This one looks pretty darn steep for down 5 and over 8. This one looks like it probably crosses about 47, down 5 over 8. This makes sense here. And again, I could be more exact. I could plug in numbers here, but I don't have an exact grid here, a graph to do that. So we've got A figured out. The next one we've got, this is a similar slope, but this time it's positive. That means it's rising going left to right. It crosses at about 7. Looks like it's a pretty, that there's more run than there is rise. So this one has more run. This one has more rise. It's a little more steep. So this one would make sense that this is B. Going on to our next one, we have -2. That's a -2 over 1. So that's, again, going to be a negative slope. It drops more than it has more drop than it has run. So I think that one would be this one here, C. And then this one is 2 over 1. It's a positive slope, so it means it's more steep. It has more rise than up to over 1, up to over 1. There's more rise than there is run here. So that would make sense that this one's D. Okay, down here we've got a little different ball game going on. We're looking at graphing inequalities. Very similar. We've got this A of x is greater than -1/5 x plus 32. In other words, the inequality that is named A is this equation, and we'd be plugging in x to find our y's. So the new piece here is that we've got inequalities, which involves shading. This one falls, it's a negative slope, so it falls going left to right. Also, it has a dashed line as the boundary. So that really clarifies a bunch of things. It would be one of these two, which the slope looks pretty similar. Looks like it's crossing about similar place. So it's all in the shading. So what we'd want to do is we'd want to check a number, plug in, and it's easiest to plug in 0. So when I plug in 0, 0, 0 for y, 0 for x, and identify, is that true? Does that fall in our range or not? So in other words, when I plug this in, I get, is 0 greater than 32? And it's not. 0 is not greater than 32. So 0 is not part of the solution set. So it wouldn't be shading over here, including the 0. It's going to shade the other side. So that makes sense that this would be A. B of x is an inequality less than or equal to 5 over 1x plus 1. So it's going to be crossing, extremely low. This one, we're going to be up 5 over 1, so it's going to be pretty steep. When we plug in 0, 0, that means these two things are going to cancel out. I'm not going to actually write them. So is 0 less than 1? And it is, so that makes sense. This 0 would be part of the solution here, so this would be B. C, we have 1 over 1 crosses at 11. We're down between these two here. This is a positive slope. It's got a solid line here, so that clarifies this right here. We can plug in the 0, 0. When I plug in 0, 0, is 0 greater than 11? No, it's not. So 0 would not be part of the solution set. That's on this side of the line, so it means we'd shade the other side. So it's evident that this is C. And that obviously leaves this to be D. Okay, something else that I want you to consider, just because I'm, making more work than needs to be, it's kind of what I do, is the point, we're going to check something else out, is the point 25, 25 part of the solution for each of these? So I'm kind of stretching things, this solution here. So 25 would be about here on the x-axis, about here on the y-axis, and where that would intersect would be about right here. And so no, 25, 25 is not part of the solution set for that. 25, 25 would again be right here, so no, it's not part of the solution set. Again, it's going to be kind of close here, but yeah, 25, 25, yes, would be part of the solution set. And here it's pretty clear that no, it's not going to be part of the solution set. So I was kind of stretching things there. Okay, in this next part, we're going to do the same thing, but I feel like this video is going to run kind of long. I'm going to go ahead and put the solutions in here, and then you can go back over and look these over later and make sure that that makes sense here for you. But I want to move to the other side of this page here, this lesson, and I want to focus in on this whole concept of line of best fit and a trend line. Data points, I'm going to read this and kind of make sure that I hit upon all the things that are important here. Data points, if we were working and looking at a set of data where you have input, the cost of something versus the number of items produced at that cost, whatever it might be, you might have an X variable, a series of X variables matched up with a series of Y variables, creating points. Those are called data points. Okay, very often in real life when we have these data points, they cluster along a line, an imaginary line. That imaginary line suggests that there's a constant rate of change. And if it's positive like this, you can assume as one variable increases, the other will increase as well. Or if it's negative like this, as one variable increases, the other decreases. They have an impact on each other. Okay, so we can very often create a trend line, which is also called a line of best fit, that can be drawn through our data points such that half your data points fall above and half the data points fall below and as near to the data points as possible. So you want to draw this line, this trend line, as close to the data points as possible so that it reflects the general direction of the data. Okay, the linear equation can actually be generated through a process called least squares regression. We're not going there. We're just going to look at, which of these lines best reflects the data. So I've got 4 different sets here, and they're in columns. And we're going to look at which line most closely represents the data given. And looking at these 3 sets here, the points are the same, but this line, half are above, half are below, but it's saying that there's no change here is what this line is saying as you move from left to right. And that's not true. It looks like there's a slight increase as you move to the right with our data. In other words, as X increases, it looks like Y somewhat increases. This one reflects that direction, but all our data points are below the line, so that's really not a good line of best fit. This one would be the best line of best fit. And let's just kind of estimate what that equation might be. It looks to me like it crosses about 1/4 of the way between 0 and 50, so I'm going to say that, A of X, this is our data set A, so I'm going to say 8 of X is equal to about, well, I said about 1/4 of the way, so I'm going to say plus 13, somewhere in there. It looks like you go up 1 and maybe over 3, somewhere in there. Maybe 1/4, but it's some partial. It's not an up 1 over 1 for sure. There's more run than there is rise in this line. My 3 isn't exactly looking like a 3, so there we go. Okay, this next set, data set B, this is falling going left to right. So there's going to be a declining, a negative slope here. We're going to call this, well, we're going to figure out which one is first. This one, all of them are above, so that's not a good fit. This looks like a good possibility. When I go down here, all of these are below, so that is not a good fit. So this one is a good fit. B of X, being this is data set B, I'm naming my function B. It looks to me like it's about, probably a negative 1 to 1. It looks like it's down 1 over 1, down 1 over 1. It's pretty consistent like that. So negative 1 over 1, or I could just write negative 1. X, it looks like it'd cross about 50. This next one, our data set really rises pretty steeply. All of our data sets are below the line. That's not a good fit. This is a good choice. Most of our data is above. That's not a good fit. So this is our best choice. Looks to me like we could come up with C of X is about, I don't know, it looks to me like it'd probably cross about 5. So we could say y-intercept of 5. Looks like we have up maybe even 3 over 1. And again, I could just write that as 3. But I'm just, again, these are not exact. I'm just guesstimating. Okay, this one I think looks pretty darn good. Half are above, half below, or about that. This one meets that criteria about half above, half below, but the line itself does not indicate the general trend of the data. Same thing here. So this one, although it's a little better than this middle one, I think there's a little more of a dip as you move, as X increases, there's a little more decrease than what is being typified here by that line. So I think this would be the better one. Looks to me like it crosses, I'm going to say D of X, naming our equation here, is equal to, and it's going to be a negative slope, but it looks to me like it goes down 1, maybe over 4, something like that. Again, I'm just estimating. Looks like to me like it crosses about 38, maybe? Somewhere in there. Again, we're just estimating. That might be a good skill to have going forward.